freshmen, join us in the quad on Friday. I think in the quad, yeah. For a little treat. Friday. Friday. In the quad. Treats. Okay, let's see. Okay, we talked about exponential functions on Friday, correct? You have two different types. What are your two different types? I said it 3 times earlier, darling. Growth and decay. Which is growth? What does it look like? It's increasing. Why is it growth? What makes it growth versus decay? Yeah, it goes like this versus like this, right? What number tells you whether it's growth or decay? Because that's the important part today. What number represents growth or decay? K is your asymptote. K tells us where we're stopping. Y is your function. Look at your notes. It tells you. What determines whether it's growth or decay? Your B. Your B determines what? Your growth or decay. What makes it growth for B? Has to be bigger than 1. Okay? So if the number is bigger than 1, then I know it's going to be growth. If it's less than 1 but greater than 0, in other words, not negative, then it's going to be what? Decay. Okay? Does that make sense? So, let's talk a couple things. What did you say? I know. He's been like on a roll. You moved by you? Yeah. Where did you live? Where? I understand where. Like, where's downtown, but where? Off. What street? What major street were you off of the freeway? You don't know? You just get in the car? And if someone had to take you home, you wouldn't know how to get home? I know students who live in Paris and right. Why? Because their parents work over here, so then they bring them over here. I know students who live down by me. So. Bless you. All right, how to graph exponential functions using exponent rules. So now you'll be on time. Okay. Guessing you live in apartments? Nice. Where at? Where is that?
It's like right around.
Oh, this is the one. This one right here?
Yeah.
I think my cousin lives in. I don't know where she lives.
I live so close, but yes, I'll be late for a week.
Until you get the detention.
Yes.
All right, let's review some exponent rules. You ready? So, let's talk about basic exponent rules for a second. Basic exponent rules. So, like 4 squared. What does it mean to be 4 squared? Now, what's the answer, but what does it mean? You're multiplying 4 times 4. Very good. And then I know that that is equal to what? 16. Good. Right? Let's review. What happens when I have negative 4 squared like this? What does that mean? Good. Negative 4 times negative 4, which is then what? Positive 16. Good. And then what happens when I do this? All right, negative 4 squared. Negative 4 squared. What's the difference between this one and that one? There's two different differences. What does this mean? Does anyone know? Nope. This means you're multiplying negative 4 twice.
Negative 4.
Wrong. This one means that you're multiplying 4 times 4 with a negative in the front.
So the negative.
So there's a 1 and you're multiplying. That's how you did it work. You put what? A 1 there? Well, God bless you. You've never seen that? I'm sorry.
I just assumed it was negative. I assumed it was positive. I already talked.
Okay. Well, now you know. It's actually going to be negative 16, yes? Okay, you need to know that rule. So this is different. Make your note. This is in parentheses. When this is in parentheses, it says I have negative 4 to the second power. This is not in parentheses. This says I have a 4 squared with a negative in front. Do you understand the difference? This says 4 squared with a negative in front. And if you plug it in the calculator, or my calculator, your calculators can be different, but my calculator is not very, it's special. So negative 4, can you kind of see it? There it is. And then if I square it, you see? And I press enter, notice I do get a negative 16. But if I put negative 4 in parentheses and then square it, I get a positive 16. Do you understand? So if you are putting it in the calculator, you need to be careful. And the reason why I'm showing you this is because sometimes you'll plug it in the calculator and you really mean this, but you do this. And guess what you get? Negative, but it really should be what? Positive. So you need to be careful, okay? There's, if you do parentheses. If you don't do parentheses, it's negative 16 like I just showed you. Okay, so you need to be careful and plug it in the calculator. Does that make sense? Especially if you're using my calculator. Some of the other calculators, no matter what, will put parentheses. This one's a little bit one step up, which means it's not putting the parentheses for you. You have to put them yourself now. Got it? Okay. So, do you understand this part? Now that you've seen this lovely little thing here, let's talk about the rules of exponents. All right, rules of exponents. So we're going to talk about, let's use 3s, because 3s are easier. Oops, let's do 3 to the third power. And we're going to expand, so what does it mean to be 3 to the third power? 3 times 3 times 3, which is 27. Good. We good? Okay. Let's take 3 squared. What does that mean? 3 times 3, which is now what? 9. Notice I am leaving spaces for a reason. Got it? Then let's do 4 to the 4. I was on 3s. Sorry. I don't know. Let's go 3. I don't have white out. 3 to the first power. Sorry. Which is what? 1, 3, which is equal to 3. Good? Now let's talk about 3 to the 0 power. Okay. We good so far? I'll let you catch up, and then I'm going to have you put your pencil down, and I'm going to show you something. So when you're ready, put your pencil down. Okay, ready? All right, so look at this pattern really quick. From what is happening from we had 3 3s, then we have 2 3s, then we have 1 3, right? We see the pattern so far? So what am I losing? How do I go from 27 to 9? I subtract? Divide by what? Divide by 3. Well, doesn't that make sense? If you lose a 3, it's not like dividing by 3? Okay. So if 27 divided by 3 is 9, right? Does that make sense? And then 9 to 3, what do you do there? Divide by 3. Well, it should be because I'm losing a 3 each time, yes? And I'm doing base of 3. Does that make sense? Okay, so I need to figure out what 3 to the 0 power is. So if I go 27 divided by 3, I get 9. If I get 9 divided by 3, I get 3. If I do 3 divided by 3, I get what? I get 1. Do you see that? Anything to the 0 power is 1. Never say 0. Okay? Remember that. You're going to need to know that. Are we good so far? Does that make sense? Okay. We're going to keep going in this pattern. If I was to use the pattern the other way, would I be dividing? You'd be multiplying, right? So if I wanted to go the opposite way, I could draw it that way also, but instead I'd say multiply by 3, right? Does that make sense? Multiply by 3. So to get to the next number, I take 27 and do what? Times by 3 to get up here, right? Do you understand? Okay, so I just want you to see the pattern both ways, but we're going to still go in the downward pattern. So now we have 1, correct? We're going to divide by 3. Now I'm going to write that on the board, and you're going to write it with me in a second, but I want you to watch. So I don't like to write 1 divided by 3 because that's really weird, yeah? And then I don't really want to see 1 divided by 3 because that's still weird. But I do know I can write 1 divided by 3. Yes? Do you see it? So, in the same pattern, if I look here though, I see 3, 2, 1, 0. What's the next number? Negative 1. So 3 to the negative 1, we just found out becomes what?
1/3.
It becomes 1/3. I read it right there, sir. Isn't it 1 divided by 3? Isn't that 1 divided by 3? It is. Do you see it? Okay, so this becomes 1 over 3 to the first. You see it? You still don't have to write yet. You can still just be watching. I'm going to give you time. Are we okay? I know I'm mind blowing you right now, like your brain is going to explode on a Monday. And then I'm going to follow the pattern again, which means I divide by what? 3. But now we have a fraction divided by 3, correct? And do we divide fractions by a whole number? No, we multiply by what? Stop guessing. What do you do to solve? And then? Oh, no. 1 over 3. You multiply by the reciprocal. So we say 1/3 times 1/3, which is 1 over 9. So, following the pattern, this is 3 to the negative 2, which we just found to be the answer of 1 over 9, which means it's 1 over 3 to the second power. Right? I know I'm mind-blowing you. Like it's crazy, right? Which is the same as 1 over 3 times 3. Yes? What do you think the next one's going to be? Let's not even do this answer right now. Let's do 3 to the negative third, which becomes 1 over what? Before we get to 27. 1 over 3 to the third, which is the same as 1 over 3 times 3 times 3, which is 1 over what? 27. Do you see it? Does it make sense? A little bit? Okay, so what I want you to notice right now is this. I'm going to move it just so you can see the whole thing. 0 is always 1, right? If I go this way, it was 3. But if I go this way, it was 1 over 3. If I go this way, it was 9. If I go this way, it was 1 over 9. If I go this way, it's 27. If I go this way, it's 1 over 27. You see what's happening? The next one's 81. The next one down here would be 1 over 81. You see what's happening? Every time you have the negative, what's it doing to your answer? It's making it a fraction. Okay? So if you have a whole number, notice there's a whole number, and I have a negative exponent, it's making it a fraction. Did you hear me? Should you write that down? Yeah, good idea. If you have a whole number with a negative exponent, it makes it a what? A fraction. So if you have a whole number with a negative exponent, it's making it a fraction. Bless you. We good? Now, we just wrote down if we have a whole number with a negative exponent, it makes it a fraction, right? So what happens if you have a fraction with a negative exponent? It's a whole number. Very good. Do you understand? So if you have a fraction with a negative exponent, it's going to make it a whole number because you're flipping it every single time. Okay? This is a rule you need to remember for IM2. We're going to do very basic right now. We're only going to deal with numbers. In IM2, you'll have to deal with variables and stuff. Okay? So just remember, if it's a negative, notice it was a negative at the top, I moved it to the bottom. Right? And it made it a fraction. But if it's a fraction and it has a negative exponent, it's going to make it a whole number. So it's just going to go from here to here. It'll go back and forth. I'm just writing what we just said. And for a fraction with negative exponent, it makes it a what? Good. All right. Make sense a little bit? A lot of it? Okay, good. Ready to graph them now? All right. Daddy, I can't speak. You ready? Okay. All right, let's do an example. Okay, we're going to make a table and we're going to graph the function. When we graph, do we need to include the asymptote? Yes. Major key concept is the asymptote. Okay? So, here comes our function. You ready? First one is f of x equals 2 to the x. F of x equals 2 to the x. we're going to make a table. Remember, our table consists of the x value. Then it consists of the function. We did this with arithmetic, right? Then it consists of your, what? Your y value, which is really f of x. Okay, I'm writing it like this because I think it's like this eventually on your test. And then it's going to be x comma f of x, which is same as x comma y. Okay? And you're going to plug in a couple points from, actually more than a couple. You're going to plug in -2 for me. You're going to plug in -1 for me. You're going to plug in 0 for me. Then I don't need as much space. 1 and 2. Okay, let's plug in. Remember, we have f of x, and we're plugging x equals -2, so we're going to write f of what? Good. F of -2 equals 2 to the -2. We don't like to say 2 to the -2. What does it become? We just talked about it. A fraction. So it's going to be 1 over 2, no, negative. 2 to what power? Positive 2. So notice it changes, okay? Notice it changes. The negative becomes now a positive. Yes? Make sense? Okay. So we have 1 over 2 to the second, which is 1 over 4. Very good. Now, over here, what I want, I don't like graphing 1/4. I don't know about you. But I'm going to go ahead and let you do a decimal only in this spot. So notice this is going to be a fraction, if I need it to be, and then this will be the decimal. Do you understand? And that's mainly for graphing purposes. So I'm going to go ahead and write the ordered pair of -2 comma, what's 1/4 as the decimal? 0.25, good. Are you okay? There are questions? All right, go ahead and do -1 for me. What does 2 to the -1 rewrite to be? 1 over what? 1 over 2 to the first, which is 1 over 2. And what is 1 over 2 as a decimal? 0.5, very good. Okay? Everyone should be able to do 0 power. Go ahead. What's 2 to the 0? 1, very good. Okay. F of 1 is 2 to the first, which is just what? 2. And lastly, we have f of 2, which is 2 to the second, which is what? What is it? 2 comma 4? Yeah. You have to say a comma. We good? Questions? All right, what are we going to do next? We're going to graph it. Before we graph it, can you tell me where your asymptote is? Where's your k? What is k? What's k going to equal, guys? What is it? What's k, guys? Your stopping line, your asymptote. What is my asymptote? Is there a k? So if there's no k, what is it?
Oh, no.
0. So is my graph going to go past 0? No. So when I make this graph, do I really need to worry about below the 0 on the x-axis? Not really. I mean on the y-axis, sorry. So notice I'm going to stop it kind of like this. Yeah? Here's x, here's y. Okay, ready? Watch me graph it so you can see how to graph it. Ready? Here we go. I'm going to graph negative 2 comma 0.25. So here's negative 2.25 is just right above it, not a whole lot of changing. Negative 1 comma 0.5 is located between the half mark. Now it's really tight. I can't really tell the difference, but it kind of is going up a little bit. The next one is 0 comma 1. So here's 0, here's comma 1. The next one is 1 comma 2. So here's 1, here's comma 2. And then the next one is 2 comma 4. So here's 2, and then there's 4. Yes? We good? Okay, watch me graph. Remember, I'm approaching which axis? The x-axis. The x-axis is where my asymptote is going to be. So I need to highlight it right on top. Notice I am highlighting it right on top of it. And then I'm going to go ahead and sketch this in. When I sketch it in, I'm going to curve it. Pay close attention really quick. Notice I'm approaching the x-axis, but am I going to cross the x-axis? No. Okay. You see how I did that? See how it looks? Okay, make yours look like that. Ready? We good? We need to do another one. Let's do, just deleting email. Let's do. I think we can squeeze it in here. I think so. It's like an example. Let's go ahead and do f of x equals 1/3 to the x. Is this going to be growth or decay? Why? Good. It's decay because b is less than 1 and greater than 0. And the other one was what? The other one was growth. Why was this growth? Because b was greater than 1. Very good. Which one's b? It's the 2. All right. Go ahead and make a table for this by yourself. If you need to move it over, I'm going to try to squeeze everything in here so I don't have to go to another page.
Same numbers as.
Same numbers, always the same numbers, yes. I forgot to skip lines. Ready? Even if you haven't graphed it yet, your table. You ready? All right, all I did was plug in the numbers like I'm supposed to. So I said f of negative 2 is 1/3 to the negative 2, f of negative 1, understand? So all I did was plug in the numbers like I'm supposed to. Now, remember I said if it's a fraction with a negative, it becomes a what? It becomes a whole number, which then becomes positive. So now this now becomes 3 over 1 to the second power. And what's 3 over 1 to the second power? It's 9. Very good. Do you understand? So then that's just negative 2 comma 9. Okay, so if I have 1/3 to the negative 1 power, it becomes 3 over 1 to the first power, which is how much? Which is 3. So negative 1 comma 3. Good? Anything to the 0 power we know is what? 1, so 0 comma 1. 1/3 to the 1 power is just what? 1/3 to the first.
3 over 1.
Why are you flipping it?
Oh, 1 over 3.
1 over 3. You plug it in the calculator as 1 over 3. You should know that decimal. It was 1 over 3. 0.3333. 0.3. It's repeating. Now, 1/3 to the second power means you have 1/3 how many times? 2, which is 1 over 9. Which is 2 comma, this one you're not going to know. I'll show you what it is. 1, what is it? 0.1? Oh, okay. I'm just making sure. Just got to double check. All right, you ready to graph? Do we have questions here? Okay, let's go graph. We're going to graph negative 2, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's way over here. Then we have 1 comma 3, which is here. 0 comma 1, which is here. 1 comma 0.3, which is like there. And then the next one is really close to 0. Where's your asymptote? Where's k? K equals 0. Very good. Did we say this was growth or decay? Does it look like decay? Okay. Questions? Comments? Summary. I did 1 of each, which should be okay. You only have 6 problems for homework. You're probably going to want paper to make the chart. Okay, I don't know how much room there is. I know the front has more room than the back of the worksheet.